So there's been an interest in making it possible to handle, basically web-based information on the browser when you're not actually connected to the network. And so, for instance, Gmail has added this functionality where you can write all sorts of emails when you're not connected to the network. And as soon as you're connected back again, there's an option to send all of that mail. And the way it's implemented in Gmail is through Google Gears. And the reason I like Google Gears is because it's a SQLite application, and SQLite is I think one of the best little database engines that you as an engineer might end up playing around with. And the very best thing that SQLite has is a very good full text index. So even though it's got a tiny code footprint, and it's hard to imagine, like if you put it next to Oracle, it's hard to imagine that these are actually a similar kind of beast. The power of SQLite is just amazing, and it's used so ubiquitously in data management applications that I highly recommend taking a look at it. So the full text index, if you want to build something that explores full text indexing, I definitely recommend SQLite as a place to do rapid development. You get a lot out of basically using that as opposed to MySQL or Oracle or any other database system that supports full text indexing. There's one sort of special purpose text indexing engine that I do recommend also. It's Lucene. So, this is definitely a very good place to start. And I'll add a reference to Lucene after the class so that it'll be on the slides. Okay. So the really interesting thing about building your data API in the right way is that if all of your data comes through a single manager, basically you can change the back API of the manager to either request from the web or request from Google Gears. So basically Google Gears, the data backend of Google Gears becomes just another source for your data. And so that's, I think, one of the really nice things about thinking of your data stream as being a single flow, because you only need to add the support onto that one flow in order for offline capabilities to start to be handled. Cool. So getting back to data consistency, the traditional transaction processing systems had very heavyweight mechanisms for guaranteeing that the outcome of a process was perceived identically for every potential user of a system. And in a web-based application, that's often too expensive to implement. And we're going to take a look at two examples of that right away. So I think that if you want a system that really has good performance characteristics, you're going to live with something that you could call just-in-time consistency, where basically you try and make sure that any updates that need to be seen by others get pushed out as soon as possible to the people who most need to see it. So basically, the way you design your data manager is to make sure that all of the layers of cache update in such a way that the people who are closest to you or who are most actively connected to you are the people who see any updates first. So I came up with this idea of, what if you wanted to, or imagine that the Founding Fathers were editing the Constitution using Google Docs. And so it's interesting because there were about 20 different authors who spent at least some time coming up with the content. And basically the performance characteristics of Google Docs are such that it's possible, for instance, to delete a paragraph that someone else might be working on. And that's the most common kind of problem that you run into in these systems where you've got multiple simultaneous editors. So people changing the same sentence at the same time definitely happens. But what's more frequent is that someone might delete a paragraph that you're working on. And there isn't really a bulletproof way of managing this without heavyweight locks. So what ends up happening is that Google Docs, for instance, maintains a time sequence of all of the edits that it's received on the server side. So a given document has a server that's associated with it, and that server is the authoritative timestamp for all of the changes that happen to it at a given time. And so if you do run into the situation where